Okay. Right. So for those of you like me who have like teenagers, story of trust, they'll never clean up your room when they tell you. And that's basically also part of this talk. Nerd alert, this was from a previous conference, but I guess here there's no alert. Everybody's here. And like to put the scope down, we really only going to focus on putting things from source to production, so not running in production, because that's another field of dealing with tampering and so on. I'm not going to tell you like scary stories about security, because that's all too easy. You all know that's important. I don't have to explain that to you. I'm not talking about changing hardware, because that's another vector, nationwide attacks. I'm not going to go there as well. I'm not talking about like human engineering or kind of tricking you into doing stuff that you don't want to do. I'm not talking about physical bypassing access to your server rooms, trying to compress the talk as much as I can. I'm not talking about key management, although it's like important, and here at FOSDem, you probably want to manage the stuff as well. Not talking about hardening your servers. Okay, so we're almost there. What I'm going to talk about, tampering, changing things, unauthorized changes. That's what I'm going to talk about. I leave this slide in here because promise theory, for those who know it, there's a lot of the word trust in there, but trust through verification. And that's going to be the crux of the talk. Like, how do we verify the stuff as well? I don't have an answer for everything, so this is a research talk. There's going to be a lot all over the place of things I found. So I hope in next iterations of the talk I will get better at providing solutions as well. But I went as far as I could from what I know right now in my research. So we're going to start with the laptop. I know it's a curse to put like a Mac here at an open source conference, but that's a lot of the reality. And we got to trust already the hardware vendor. We got to trust Apple. We got to trust the operating system. So I'm going to take that as a starting point. The developer's laptop with the certificate authority is on there, with everything in there, and it's updated. So I kind of start from there. These days, a lot of the development is actually assembling more and more libraries. If you're doing some development on a Mac, there's the App Store, there's Docker, NPM if you're Node, Homebrew, because Apple doesn't provide all the tools you actually need. So, it's nice to have the community, but we depend on a lot of other libraries actually to even start our job and get the information before we can even start developing. So the first thing we trust is kind of all these kind of external dependencies. And most of them are actually based on, some form of TLS verification, chain of trust. I don't have to explain to this crowd. Any configuration, ciphers, all that stuff, certificates that we think that is happening underneath because, we're using HTTPS and it should magically be taken care of, right? Obviously, leaked or rogue CA certificates, but, that's another story. We'll leave that to the pros and all the ciphers and so on. So I'm taking this example of a Node app trying to push that to production. The Node, by default, has a lot of ciphers it supports. So it has to support it because it's quite open. So we're trusting it, but we can get better at, putting this down. It's as easy even as putting some environment variables and kind of saying these ones we don't want. So it's a simple thing you can do if you don't want just rely on Node, just doing stuff in there as well. I have to take my glasses on and off, I'm sorry. What's interesting is that a lot of we think about certificates being validated. Yes, most of the time it actually validates whether the certificate has been expired, but it doesn't look at revocations. So, for example, you can, CRLs and so on, you can verify it, but in several of the libraries, it is just not available. Let's Encrypt has kind of made this better. but we're still not there yet. If you want to go a step further, you look at the SSL, the certificate is valid, you look at the revocation stuff. The next step is actually, like, what other certificates got created for my domain? Facebook provides like a nice interface to kind of check whatever certificate that was created in your domain. So that's a way of detecting rogue certificates being created under your domain that you can validate. So you can put a webhook on there, monitor your domain, and kind of get information about things, certificates being created there as well. And if you want to go one step further, you can put in DNS the CAA record that actually says, well, if this record, if this certificate has been created, by which authority has it been created? Because maybe there's some dodgy kind of CA that creates a certificate for your domain, but here you can specify it in DNS, which ones do you trust? I'm not saying this is widely used, but it's like one of the trust verification system we can use in the system. So we kind of, went a little bit deeper on HTTPS and validation than usual. Yes, it's HTTPS and we're happy. Kind of a couple of things we could do. But obviously, there's the next problem is DNS, right? Because we want to do a request, but we want to do a DNS request. And, well, I'm sorry to say it still isn't solved. And many would think like DNSSEC is kind of the answer. But if you look at a few of the major ones, like NPM and GitHub, don't have DNSSEC enabled. So that was a surprise to me. I was like thinking, yeah, this is DNSSEC. Everybody should be doing it. I know it's hard, but I would have expected these companies to be doing it. Even curl doesn't check it. Like, there's like a 6-year-old open pull request to do it. Like, my trust in curl has gone way down. I'm not saying it's not a good tool, but obviously it's people. But the more you look at the things under the hood, the scarier things kind of getting there as well. And then, okay, we got HTTPS out of the way. We kind of trust that. We got the DNS. We kind of assume that trust as well. And then the next thing you do is like a homebrew says us like, run this kind of Ruby execute from GitHub on your laptop. How many have done that? Yeah, scary, right? So I don't know why it doesn't seem to, be able to get better to do it. There's a tool I found like PipeDis that allows you to actually view whatever has been piped to the bash command, that you can review the commands being executed. Gives you some kind of visibility of the things that are happening. But again, like we just take that for granted, right? So homebrew, right? Let's do it. Node is a little bit better in a way that at least we can do the curl download and check the validity of the binaries. They have GPG enabled, so which is nice. But okay, just going to go back on this slide. Nope. Okay. But it still is kind of a whole ceremony to go through, right? I rarely do it, but it's like one of those things. It should almost get baked into the tool somehow in the future as a step that just says, I downloaded it, it's validated, it does all the checks. Currently, across all the package repositories, there's no standard way. Everybody does it differently, and you kind of have to figure out, and sometimes it's not even well documented, and you have to spend a lot of time to actually verify the stuff. Docker was an interesting one. I wanted to have Docker desktop on my laptop. I could not find it. Check somewhere on a website that was able to verify the DMG that I was downloading. The only way I could verify it was if I install it on my Mac using App Store, and then I could verify the signature. And that was documented. But then again, we go through the chain of trust that we have to trust like Apple and kind of go around that. So that was a little bit surprising for me to see, we can kind of do that with a Docker binary and verify that as well. Okay, I got like Node, I got like Docker, a homebrew. So now, I'm going to install some libraries, right? if you look at libraries, how do you think that a library is secure, right? Oh, if there's like 1 million people using it, it's secure. If it's like been there a long time, it's secure. So I haven't really found a good way. Obviously, it's kind of like verifying multiple vectors, but there is no kind of good way to verify it. There's a lot of vulnerability scanners that will report you CVEs or something on something. But if it's like a library not well known or a new thing, it's like really hard to verify unless you kind of download or compile everything from scratch yourself and go from there. npm install is interesting because it actually, like many of the package managers, just runs also scripts when you do that. So you can change a lot of stuff on your laptop as well. So you can, for example, use npm install with ignore scripts and say, well, don't run it, and get like a preview of the scripts it's going to execute, and then do the execution. So it's like a next layer you can verify what is actually going on underneath. It's very clunky. Of course, we don't want to have like advertising in npm. Who remembers this happening? Nobody? So for a while, when you did npm install, instead of only giving you the packages that it installed, it will just show advertising in your CLI tool. There was a lot of debate of something happening, but it kind of shows you what these package managers could do to your system if there's somebody who wants to do some stuff with it. So you kind of do the scanning, you find all the bugs. One of the problems, obviously, is kind of all the dependencies in the libraries. Like a bug could be DDoSing it, but you're using it internally. So even with all the scanner tools, it's really hard to figure out like where do I spend my time patching. So that's one of the problems, prioritization to do that. You can take a step further of the scanning of libraries and do it at a proxy level. Like JFrog X-Ray allows you to do the scanning and not allow you, when you download the packages through an upstream repo, and that they're like secure or verified or not. So you don't have to do it on your laptop. Obviously, you have to trust JFrog X-Ray, but it's kind of another layer of control you can put there as well. So this was just to point out that Homebrew, the only thing it actually does is like looking at the checksum of the tarball or something it downloads. So the actual recipe, or was it the brew, that itself is not signed. And the maintainer said, we're not doing that. We're an open source project. We don't have time for that. That was basically kind of the answer. So it's, it's kind of interesting on something we're using so much on our laptops to install stuff, that this is kind of the state where we are. Node is a little bit better. They kind of signed their dependencies as well. They have like checksums, but you can see like this is all manual steps that you need to go through. But at least you can verify it. You can get their GPG keys. You can verify the stuff. So that's nice. And obviously, when you commit things yourself, you can sign the signatures with your GPG key and push things to Git. But I found an interesting project that allows you actually like multi-comments, or what is it, multi-submitters that you do in Git, that there is like a solution for multi-signing it, a commit. So not only one person, and then you can say, well, before it goes into production, multiple people have to sign that commit before it actually goes out. So that's another way of verifying things there as well. If you're using GitHub or something similar, when you push things, these fingerprints of the official host keys are actually documented, so you can verify those as well, instead of just saying, yes, I trust, first trust, and push it to the server as well. It can kind of be like anything that has like a SSH key at that point, you can kind of push to, but at least here you can verify the official ones. That brings me kind of to principle of TUF. Who has heard of TUF? A few people. So it's kind of known in more in the Docker sphere, is spreading towards more of the applications and the package distributions. So TUF stands for the update framework. So they kind of made some principles and some guidelines of people pushing things to repos. So the separation of duties, more like multiple keys and not one key to kind of push things. Thresholds, much like the Git commit signing, they do the similar thing, like multiple people, depending on the step, have to kind of say yes, not only one. So that builds like the consensus, much like what was it? The certificate thing I talked about. The revocation of keys is really important. So it's built into the framework that they can fast rotate keys to make sure that there's like no delay. Offline keys, so the root keys don't need to be active all the time, so they can be on offline storage, and then the trust goes up for more like shorter keys to be there. And no need for the key sharing, so everybody can kind of delegate a key to somebody else depending on what the job they do. So there's a principle, look it up, the update framework. I'm just rushing over here, but it's an interesting read as a concept. And this is what actually is used by Docker Notary when you want to push images that are signed and secure. Those principles are used by Docker Notary. So you create a key, you sign it very much like any of the package repositories as well. And then you can expect whether it's signed with or correct to, like you would do with a Git commit, but now with a Docker image as well. This actually has saved a major breach on the Docker hub by requiring multiple people to do a certain step. One of the keys got compromised, but they recovered in a way because they had this principle available in the setup. We've talked about Node code or any of Ruby or whatever code. We talked about Docker images, but there is also something you can do for verification. For example, for JavaScript libraries in the browser. So you can build a checksum and you can make sure that there's an integrity check when the code gets executed in the browser as well. So it's the checksumming and so on, we just keep going and we can verify more and more. So that's a good thing. I'm taking it even further. We talked about code, but this is probably the simplest way in the days when I was running Apache, like -t was my friend to validate the code or the config as well. I'm not saying this is the trust, but at least it gives you some kind of idea of what is happening. And if you want to take that further, now with something like tfsec, we can basically check your Terraform code to validate if there's something happening that shouldn't be happening as well. I think that's getting powerful, more in cloud configs, that we can actually do that verification as well. Taking it one step further, so I'm just going up and up. So what if I don't trust my laptop every time I do some stuff? I think Jess Roselli has coined this idea of running every application inside of a Docker container on the desktop. 2015, this was a blog post. Now there's been a couple, Visual Studio Code, you develop code inside your containers, and then we get better at exporting, like debugging it from remote. Fedora has a similar project, and something like CubeOS goes a step further. They even give like every application, the way I understand it, they give every application their own network stack, their own everything. And everything stays like separate and ephemeral. And it's actually used for journalists to make sure that when they're putting things in the news, that they have like a safe environment where they can edit stuff and they can kind of make sure that it hasn't been tampered with. So one of the points is that I know a lot of people say, servers, scale, not pads, but I think we're going the direction that it's going to be the same for the desktops. When I said that, I heard like developers screaming, like I cannot have my own autonomy and so on. I was like, yeah, I've heard that before, like 10 years ago on the server world, giving pets names. We were just discussing that, like Pokemon names or whatever. So we got the code verified. We're pushing it now, hopefully, to the CI, we pushed it to the Git repo, and now hopefully the CI kicks in. But what's interesting is that this often is outside our control. So it's like who watches the watchers, who trusts the people we trust. So this is a nice paper to read if you want to know more. I don't know if anybody knows that project. But yeah, it's just, it's in a fun way. It shows like anything can happen in your CI system that you don't know that's going to happen as well. And that makes you think, like, if you use like a SaaS solution, how do we get that same trust? We can't verify the binaries. We can't do everything. We pay them or we use them, and we just assume they're secure. So that's like a big leap up. And I haven't got any, perfect solution for it, but there's obviously they get better at exposing what they do. So they show you the images they run your builds on. They share that officially, but we don't have any idea whether they're running this image. So it's still like, it's better. Some have a solution to run things on-prem, so they would do the same orchestration, but they run it on your machines. So at least you can kind of get audit logs, kind of see what commands get executed. So it's not perfect. Some would have like a more of they would officially announce that there was an audit of the code. So that's kind of how more and more they are building trust. Some would allow you to limit the IP addresses. Let's say if your build system is remote, they have you push things to your environment, that at least you only allow the IP addresses of the people who are pushing something to you. And this is a nice little trick. For example, if you use any of the AWS CLI tools, you can change the user agent, and you can have like an EIM profile that says like only this user agent is allowed. So you can turn that into an almost random key by obscurity that allows you to kind of say, well, nobody else, even though they have like the AWS credentials, can actually use that if they don't know the random key that you put here. I'm not saying this is secure, but it's like one step more. The people from the Bitcoin system, they went a step further. So they just went with, what if we have multiple people compile it and then verify if this gives us the same result? And then if most of the people get the same result, we assume that is the best result. And then we put the checksum in. So not only one checksum, because your tooling might be infected, and just changing it there as well. So I found that a nice way. We sometimes think about multi-cloud. What about multiple CI? What about using 2 CI systems and then do like verification and see if both kind of created the same thing? Again, it's like thinking. I'm not saying this is actually being done, but it gives you some inspiration. But this brings us to the hard point of doing reproducible builds, which isn't really that easy, because let's say you have like something like a time in your banner or your header or whatever, and you're kind of recompiling it. The next time you compile it, the binary will be different, or the flags from the compiler or anything there. So Debian has spent a lot of time on making packages and builds reproducible. Node, if I run it twice on my same laptop with the same compiler and the same settings, the binary or whatever it builds will not give me the same checksum. So it's something that I found interesting to see. We would think like a checksum, this is kind of what we do. One more step further, what about the operating system itself? It turns out that this was from a FOSDEM talk. To build a Linux, nowadays you have to have a Linux, right? So somewhere we lost the link from being completely from scratch to build the Linux system. Sometimes you see like Bootstrap 1, 2, 3 when you do like GCC compiling. Like some of the bootstrapping is binary only. So people are still working on making that code as well. So it's sometimes hard to verify to do that. If you want to have a look at this, this is, I think there was a talk earlier today on that as well, UX SD, like all the dependencies of the libraries. It's not that easy as it looks. And even like the bootstrapping assembler, that people are working on that just to have like a from source verifiable compiler to make things happen. I'm going to skip that slide. Right. So we kind of said, well, make it repeatable, and then the hacker say, fantastic. Now I can detect every binary because if I look at the checksum, I know what binary it is. So then this company said, well, you know what? We're going to build a wrapper that randomizes the checksums again to run it in production, and then we map it on the static checksums again. So it's kind of, we're going round and round, but we're getting better. The checksumming is one thing. I talked about thinking about all the dependencies. I think this is where Google Bazel comes in, that they, instead of saying reproducible builds, which build the same binary, they're working on the concept of hermetic builds, where all the dependencies that you need in the build for your Docker image or whatever, they are specified. It is not just apt-get update or something. They kind of try to do that as well, and not only for your dependencies, but also for your compiling toolchain. So Bazel will download a known set of compilers so that everybody in your team will use the same compilers and do the same installation as well. And that brings us, the attack vectors. Quite often the discussion is on containers, like, oh, there's so much in the container and then there's so much vulnerabilities. And they're actually going the direction, what if we only need like one binary in the container? So distroless, and that, makes it a lot more difficult to do any attack vector there. This is what some people are working on. So when we know all the dependencies, we kind of have like a bill of material, like the ingredient list. This code has been built with these dependencies and so on. Well, there's many tools that allow you to reverse engineer Docker files because it's sometimes not that easy and you don't know what's inside. You can take multiple approaches, either from forensics or reverse engineering. They're all in the notes. You can check that later. So some interesting stuff. But, it's stupid that we throw away all the meta information while building and then have to reverse engineer it again. In my past company, I worked on video stuff, and it's almost like when you have a DVD, I know that's getting old, with subtitles, and you have to reverse engineer it from the image. But that's actually stupid. Intoto is a new, not new, but it goes one step further. They actually not only specify the dependency sources, but also the steps that they took while doing the build. So they would sign every step of the build so you can verify what happened during the build as well. And then Graphias in the Docker ecosystem can use all that metadata to decide whether something should run in production or not. Based on what has been in the image, when a new vulnerability comes out, they can kind of say, well, this is kind of something that has been built. Now we know there's a severity 1, so you have to do about it. But that's something that can be integrated there as well. But obviously, it never ends, and we just keep going there as well. So I'm getting toward the end of my talk. I know all the tools that I've shown you are so hard to use, right? And sometimes I think about it, we fought so hard to get the right to vote, but then you would say, well, I don't want to vote, right? And it's a little bit like this. We fought so hard about getting the freedom for, sharing libraries and so on. And I think we kind of have to get better at the verification step because, that's one of the duties we have as well to make our ecosystem more secure in there. And I think a lot of it has to do with the transparency, building consensus, so not like one group saying yes or no, but work on there as well. So I think that was basically my talk. I don't know if you have time for questions.
You have time for one or two.
Okay. Anyone? Yeah. Okay.
What do you think about commit signing?
I know there's quite some debate whether it's useful or not. Yeah. But I think if you automate it, that's one of the problems. Because if it's just like I will do from what I understand, the argument is about when you automate the step, then it's no use because it's there is no real verification happening. I don't know if you have another idea on there.
For instance, not to build something that is not signed properly. Prevent building code that is not signing.
Yeah, but sometimes you have to, I guess. No?
Is it possible? Are there any tools that they can use to prevent build something that is checked?
Oh, okay. I think the question was, is there a
Two questions.
oh yeah, okay. I'm going to repeat the second one. So that can prevent a build from happening if the commit hasn't been signed. I think that is probably looking at the verification and then putting an exit code. I don't know. I haven't come across any specific tool in there. So.
Yeah. Well, very interesting, by the way.
Thank you.
The presentation was really, really good. You talk about the pipeline. What happened? What is already in production?
Yeah. Okay. So that's another talk. Like I said. Yeah.
Because I think that's more dangerous, actually. No.
It is more dangerous, but I think it's another aspect of looking at things. I think here I want to go in the prevention mode and not in the
But even if you go into prevention mode, the hacker
sure
is quite fast.
Yes.
And the community is quite fast, trying to find vulnerabilities and things that are disclosed already, but the companies didn't have time to patch it.
Yes. Yeah.
So how do you inform the companies?
But the visibility